And good morning, everybody. Here are the notes for section 2.2, and it's going to cover the basics of the general sine wave. And here is the complete form for a general sine wave. So there's going to be 4 different transformations. The first one is the A value, and this is going to be changing the amplitude. And one thing that you need to watch out for is that the amplitude is always going to equal the absolute value of the A value, and it is going to basically be the height measured from the midline of the curve. So it's the height from the center of the graph. So if you have a sine wave, and let's say it goes as high as 2 and as low as -2, and let's say its full cycle length, its period was 2 pi, then the amplitude would be measured from the highest point down to the midline, or you could measure it from the lowest point up to the midline, but they're both going to be a value of 2. So we would never say we have a negative amplitude, we always just have a positive height from the center of the graph to the highest or lowest point. So that's going to be the amplitude. So we'd say the amplitude is 2. The next letter in the equation we're going to talk about is the D value. So the D value is the vertical shift. And the vertical shift is going to be transforming the graph up or down. So if you start with a sine wave, and if you look at your 5 key points, and let's say we happen to have, let's say it was a basic sine wave, y equals sine of x plus 1, then that means all your points are going to shift up 1 unit. So we're going to take our new points and let's put a scale on our graph. Let's say this was at 1 and at -1, and let's say the cycle was 2 pi long. So these 5 key points are going to shift up 1 unit. So we'll need more scale in the vertical, and we'll shift them all 1 unit. So this will go up 1, up 1, up 1, up 1, and up 1. So that's going to be our new sine wave. And notice it also shifts that midline up 1. So if you're looking at this graph, you should also notice that the midline is shifted off of the x-axis. Everything went up 1 unit off the x-axis. So that's going to be your vertical shift. So vertical shift. And the next value we're going to talk about is the C value. And this is going to be the horizontal shift. So horizontal shift, and it's a little opposite of what you would think. It's always x minus c. So if you see a trig function that reads y equals sine x minus pi over 3, clean that up, pi over 3, then this is going to be a shift to the right, since it's always x minus c. So you always have a minus in the general form. If you see x minus, So x minus is the general form. Then the c itself is just going to be pi over 3. So it's going to go to the right pi over 3. If you see something with a plus, so if you saw y equals sine x plus pi over 3, then since the general form is always x minus, then in order to get a plus here, in order to have a plus sign right here, then you would need your c value to be negative pi over 3. So your c value, when you're looking at just your c value from here to here, this is the general form, x minus the c has to be negative pi over 3, so it's going to shift it to the left, negative pi over 3, so it's going to go back pi over 3. So that's going to be your c value, and they call that the phase shift. So c equals the phase shift. And the last value to talk about is the b value, and this is going to affect the cycle length. So this is going to change the length of one cycle, or one repetition of the graph, and we call that the period. So that is called the period. They often call these periodic functions because they repeat themselves periodically, and how long they go for one cycle is what we call the period of the graph. So a traditional parent function, a traditional sine wave, y equals sine x. If you look at a traditional sine wave, the parent function always starts out going as high as 1 and as low as negative 1. And then it goes, if we break this off into 8 boxes, 4, 5, 6, 7, 8, and we call that 2 pi. And if we plot our points, so sine starts at the origin, goes as high as 1, at pi it's 0, at here it's negative 1, 2 pi, so that's going to be our sine wave. So that's going to be our sine wave, so that's going to be a period of 2 pi for it to complete one cycle, so that's the period. So period is going to be 2 pi, and that's for the parent function. If we have a b value, so this b value is going to affect the length of the period. So basically what the b value is going to do is it's going to multiply the angle by a particular factor. If it's bigger than 1, it's going to speed the cycle up. If it's a fraction less than 1, then it's going to slow the cycle down. So for example, if you had, instead of y equals sine x, if you had, let's say, y equals 2 sine of x, so let's change our function. So let's say we had y equals sine of 2x, then whatever angle you're putting in for your x value, it's going to get doubled as soon as you put it in the equation. So it's going to make it rotate around the circle twice as fast. So your new period isn't going to be 2 pi, it's going to make one rotation twice as fast, so it's going to make one rotation by the time it gets to pi. So the formula that we use to try to find the new period, to find the period, you can always do 2 pi divided by the b value. So in this case, our b value was 2. So if you do 2 pi divided by 2, then that's telling us that our new period, the new period value for one cycle, is going to be pi. So you're going to need to adjust your scale when you're doing these new problems. You're not always going to have a rotation of 2 pi or a cycle length of 2 pi. So you're going to need to adjust your x scale so you can accommodate the new period. So let's go ahead and do a quick example of that. And let's just go ahead and finish the equation we had. So we had y equals sine of 2 times the angle. So this is our b value. So this is our b value. So again, the period is going to be 2 pi, the full cycle, divided by the b value, which in this case is 2. So our period will be pi. So if we go ahead and draw our graph, we're still going to use 8 boxes to represent 2 pi, or sorry, not 2 pi, to represent one cycle. So there's 4, 5, 6, 7, 8. So we're not going to call this 2 pi anymore, we're going to call this pi, which means 4 boxes, half of that, 1, 2, 3, 4 will be half of a pi. And then half of the half is going to be a quarter, so that's 1 quarter, 2 quarters, 3 quarters, 4 quarters to make the whole pi. And the amplitude is not changing, so the amplitude will still be 1 and -1. And once we have our new cycle length plotted, it's going to kind of look the same, but the only difference is the scale. If you look at the numbers on the scale is going to be different. So it's going to have the overall same appearance on the page, but the scale is very important. So you need to make sure you change your scale to represent the new cycle length. And let's go ahead and plot our new points. So 0, 0. 1, pi over 2, 3/4 pi, and pi. So that's going to be our sine wave with a period change. So that the period from here to here, one cycle, is going to be pi. So that's going to be your period of pi. And here are a few examples. The first one we'll do is y equals sine of 3x minus 1. So first thing we want to do is we notice that we have a b value. So that's going to change the period. So you want to set up your scale first, since you're going to have a period change. So you can set up your x-axis, and then you can do the transformations after that. So we know the period will always be 2 pi divided by b. So your period is 2 pi divided by b. In this case, our b value is 3, so it's going to be 2 pi divided by 3. So one cycle length is going to be 2/3 of a pi, or 2 pi divided by 3. So let's go ahead and set up our x-axis. And we'll still use 8 boxes to represent one cycle. And we're not going to call this 2 pi anymore, we're going to call this 2 pi over 3. So 2 pi over 3, which means half of that, if this is 2/3 of a pi, then 4 boxes is going to be pi over 3. And then see if we can make that a little bit neater. It's supposed to be a 3. So 1, 2, 3, 4 pi over 3. And then half of a third, that's going to be a 6. So every 2 boxes is going to be 1 6. So 1 6, 2 6, 3 6, 4 6 to make the 2/3. And then from there we can go ahead and graph our sine function. So we'll put in the 5 key points. So sine starts here, goes as high as 1, down to -1, and that's going to be our sine curve. So that's our sine wave. Missed it a little bit. So there's our sine wave, and that's going to be the period change. So we have a graph of the period change, so we can check that off. The next thing we need to look for is the fact that we have a d value, so that's going to shift the graph down by 1 unit. So we're going to need some more negative on our scale. And all 5 of these points are going to shift down by 1 unit. So this is going to go down, this one will go down, this one goes down, this one goes down, this one goes down, and that's going to be our sine wave with a vertical shift of -1. And then you want to see if you can answer some basic questions about this function. So a lot of times they ask you for the 5 key points. So you should be able to go through and list off the 5 key points. So if you have a clear graph, you should be able to look at these ordered pairs and your scale and list off those 5 key points. So looking at the 5 key points, the first one's going to be at, looks like 0. So 0. So first key point is at 0, comma -1. The next key point, if this was a third, then 2 boxes is going to be a 6. So your x value is going to be pi over 6, comma 0 on the y value. And the next one's going to be at pi over 3 for the x, comma -1 for the y. And we're going to go 1 6, 2 6, 3 6, 3 over 6. That's going to be pi over 2 if we simplify the fraction. So 3 over 6, that's the same thing as 1 over 2. So pi over 2, comma -2 for the y value. And the last one is at the end of the cycle, so 2 pi over 3, comma -1 on the y value. So those are your 5 key points. And other questions that they might ask you for the period. If they ask you for the period, you pretty much have to answer that to do the question. So your period would be here. Your phase shift, if you wanted to answer the question on the phase shift. So your phase shift, in this case it didn't shift left or right, so your phase shift would be 0. You didn't have a C value, you only had a B value. So you had a B value and you had a D value. So you didn't have a C value, there was no shifting left or right, so your phase shift would be 0. Your amplitude, so your amplitude is the height from the midline, or the absolute value of your A value. So in this case, your A value was just a 1, you just had a 1 in front here, so A was 1. And also if you look at the midline, remember the amplitude is the height off the midline, so your midline is at y equals -1, so your height is just going to be 1 off the midline. So your amplitude is going to be 1. So amplitude equals 1. And another common question, they might ask you for the range. So the range of the function. So if you remember from some of your algebra courses, the range was the y values, domain was the x values, range was the y values. So the y values are going to range or oscillate between which values. So if we look at our graph, it looks like the y values go as high as 0, so y equals 0, and they go as low as -2. So we could say our range is going to be from 0 to -2. So that's going to be your range for that particular function. So 5 key points, period, phase shift, amplitude, range. So we have our 5 key points. We have our period listed. We have the phase shift. We have the amplitude. And we have the range. Those are going to be some common questions that you might be asked, plus graphing a good graph of one of those fundamental cycles. And let's go ahead and try another example problem. So this one we have all 4 transformations, all 4 letters. So let's look at it before we start graphing. So we have an a value. So the a value is -1/2. This is going to flip the sine wave upside down, shrink it by 1/2, so it's going to be not as tall, and its amplitude, its a value is a -1/2, but its amplitude would be +1/2, since amplitude is always positive. We also have a b value, and the b value is going to change the period of the function. We'll want to do that first so we can set up our scale. We're going to have a c value that's going to be our phase shift. So this will be our phase shift, and it looks like it's going to go pi/6 to the right. So pi/6, and it's positive, so we're going to expect it to go to the right. And then we also have a d value, which is our vertical shift. So vertical shift, and that's going to go down 1 unit. So we're going to go down -1 on our graph. And let's go ahead and start graphing. So the first thing we want to do is find the period. We know that the period is always going to be 2 pi divided by b. And in this case, our b value is 3, so it's going to be 2 pi divided by 3. So one cycle length is going to be 2/3 of a pi. So let's set up our x-axis. And we'll try 8 boxes. One, 2, 3, 4, 5, 6, 7, 8. And we're not going to call that 2 pi anymore. We're going to call that 2 pi/3. So 2 pi/3, that's going to represent one cycle length. And let's just make sure you can find your pi/6, your phase shift on this scale. So when you have a phase shift, you need to kind of make sure you have a scale that accepts your phase shift. So we need to be able to know where pi/6 is on our scale. So if this is 2 pi/3, then we know 4 boxes is going to be pi/3. And if this is pi/3, halfway to 1/3 is going to be a 6. So this is going to be pi/6. So it looks like 2 tick marks is going to work out to be pi/6. So that's going to be able to accept our phase shift horizontally. So this looks like this will be a good scale. And let's go ahead and graph our sine wave. So let's go we'll have 2 boxes, be a value of 1. And let's put in the parent function. So we know sine starts here. It's going to go to here, and then 0, and then -1, back to where it started. That's going to be our parent function with a period change of 2 pi over 3. So there's our sine wave. And then let's go ahead and apply the amplitude. So let's apply the A value. So the amplitude is going to change. It's going to have an amplitude of 1/2. It's also going to get flipped upside down because of the -1. So 0 times -1/2 is going to be 0. 1 for the y value times the -1/2 is going to make it -1/2. 0 times the -1/2 is going to be 0. -1 times the -1/2 is going to be +1/2. And then 0 times the -1/2 is going to be 0. So there's going to be our sine curve that is reflected over the x-axis and made half as tall. So its amplitude is going to be 1/2. And now we can go ahead and apply the shifting. Most students prefer to do the shifting all in one move. You can do it in 2 separate moves. We know it's going to go to the right because of the phase shift, and it's going to go down because of the vertical shift. So it's going to go to the right pi over 6, and it's going to go down 1. So before we start shifting any points, let's just kind of get our bearing straight. We know that going to the right pi over 6 is basically 2 boxes on our scale. So it's going to go to the right 2 boxes. So we're going to go to the right 2 boxes. And we're going to go down, and according to our scale we're going to be going down 1 unit, so that's going to be 2 boxes down, so 2 tick marks down. So every point on the green graph is going to go to the right 2 boxes and down 2 boxes, so we're going to need some more vertical scale in the negative direction. So that's going to be -2. And everything's going to go down 2 boxes and to the right 2 boxes. So the first green point is going to go 2 to the right and 2 down. And the next one is going to go 2 to the right and 2 down. And the third point will go 2 to the right and 2 down. And then 2 to the right and 2 down. And we're going to go 2 to the right, so we're going to need some more horizontal scale. So we're going to go 2 to the right and 2 down. And then we'll try to sketch in our curve. And that is going to be our transformation. So the yellow one should be your final answer for the graph. So this is our final graph. And then you should be able to answer all the different questions that are asked in the book. So a lot of the questions are the 5 key points. So make sure you have a clear enough graph. Use graph paper so you can list the 5 key points. The range, which is all your y values. The amplitude, which is the absolute value of A. And the period, and the phase shift. So you'll need to make sure you can answer all those questions by looking at either the equation or looking at the final graph. And here's going to be the last example for this video. So this one, it doesn't have as many transformations, but it does have a little curveball here. Notice that the b value is factored in to the x minus c statement. So if you look at your general form, so the general form for any trig function, whether it's sine, cosine, tangent, should be y equals the a value, sine or cosine or tangent, and then we have one layer of parentheses and the b value, The x minus c statement needs to be by itself without the b value factored in, and then you have your plus d. So what you don't want is you don't want to work with an equation where they have multiplied the b into the x minus c. If they have, then you want to factor the b off. So if your b is in there, so let's say you had your b distributed in, so if you have b times x minus b times c, if you don't have those two-layer parentheses, then you need to factor the b off of the x minus c so that you get your b factored off and your x minus c all by itself. So you really need to have x minus c by itself. It's not going to change how you perceive the b value, but it is going to change how you perceive the c value or the phase shift, which will throw off your final answer. So we're going to have to factor off that common pi over 3, which is the b value factored in. So here's the equation with our b value factored off. So we factored off the pi over 3 on both terms. So the b value is pi over 3, the c value is 1, so let's find our new period. So we know the period is going to be 2 pi divided by the b value. In this case, the b value is pi over 3. So we're going to have to work this out. We're dividing by a fraction, so we're going to have to multiply by the reciprocal. So you have 2 pi up top, over 1 if you will, multiplied by the reciprocal of the bottom fraction, 3 over pi. So there's our reciprocal. And the pi's are going to cancel. And final answer is going to work out to be 6. So our cycle length is now going to be 6. So you don't always have to have a period with a pi in it for a trig function. You can sometimes just have a repetitive cycle length of 6. That's going to be helpful when we're trying to use this to model real-world applications. Not everything repeats on multiples of pi, so it's going to let us switch over to something that is a little bit more useful. So let's see if we can fit this on the screen here. So we're going to go and set up our scale. And we will try and use 8 boxes eventually. So let's go ahead and try 8 boxes. Eventually you'll get into problems where 8 boxes might not be a good scale. You might have to switch to 12 boxes, but if it fits, then 8 boxes usually makes a good size graph. 1, 2, 3, 4, 5, 6, 7, 8. And that's going to be 1 cycle length. So remember, our cycle length is going to be 6 long, so 8 boxes we're going to call 6, which means 4 boxes is halfway to 6, so 4 boxes is going to be 3. And then halfway to 3, that's going to be 1.5. And then halfway between the 3 and the 6 is going to be 4.5. So that should be our scale for this particular cosine curve. So remember, we're graphing cosine this time, and let's go ahead and say 2 boxes will be a unit of 1. And let's graph our parent function. So cosine starts up high, goes to the x-axis, goes to its low point halfway through the cycle, back to 0, and back to a output of 1. So it's going to be our cosine curve. So there's our cosine. And then we just need to make the transformation on it. There's only one transformation in this one. That's going to be the c value. So it looks like we're going to go 1 unit to the right. So the phase shift. Will be 1 to the right. So where's 1 on our horizontal scale? So this is going to be 1.5. So let's see if we can determine where 1 is on the horizontal shift. So notice if we try to find our phase shift of 1 to the right, that's going to be difficult to find on the scale. It's going to lie somewhere between the tick marks. So in this case, 8 boxes was probably not the best scale to represent a period of 6. So often if 8 boxes doesn't work, you could often use 12 boxes because 12 is divisible by 2. You can divide it in half, you can divide it in quarters, you can divide it in thirds, you can divide it in a 6. So let's go ahead and try a different scale. And I actually learned something new here. I learned that I can actually set some graph paper as my background. So let's go ahead and try this on a different scale. So here we're going to choose 12 boxes to represent a cycle length, which is going to be 6. So there's 12 boxes. So 6 boxes will be 3. 3 boxes will be halfway to 3, so that's 1.5. So every 2 boxes is going to be a value of 1 unit. And remember, we're trying to do a C value or a phase shift. We're trying to do a phase shift of 1 to the right. So every 2 boxes is going to be a unit of 1. So we're going to take our graph and we will shift everything 2 boxes to the right. So 2 boxes to the right, and we'll need to do a phase shift of 1, and that's going to be your graph with a phase shift to the right and using a scale different than 8 boxes.